Alright, lesson 4.5 is isosceles and equilateral triangles. Theorem 4.3, the isosceles triangle theorem, says that if two sides of a triangle are congruent, then the angles opposite those sides. So here, side CB is congruent to side CA, so angle A is congruent to angle B. Theorem 4.4, the converse of the isosceles triangle theorem, says that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here it says angle A is congruent to angle B, so side CB is congruent to side CA. Alright, theorem 4.5, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So, line CD is perpendicular to line AB, and CD bisects AB. So if it's perpendicular, that means both of these angles are 90 degrees, and that means this is congruent to this side. Okay, then we have a couple corollaries. There's a lot of theorems here, people. Corollary to theorem 4.3 says if a triangle is equilateral, then the triangle is equal angular. So if you know all the sides are equal, we know all the angles are equal. So angle X is congruent to angle Y, congruent to angle Z. So then the opposite of that, if a triangle is equiangular, then the triangle is equilateral. So if we know all the angles are the same, then we know all the sides are the same. So side XY is congruent to side YZ, which is congruent to side ZX. And a corollary is a statement that follows directly or follows immediately, either one. From a theorem. So because of a theorem, we have this extra statement that goes with it. Okay. Then a couple more definitions, and then we're going to jump into some examples. The legs of an isosceles triangle are the two congruent sides. These two congruent sides that are marked with the dash are the legs. The base of an isosceles triangle is the third side. So the one that's not congruent, this is the base. The vertex of an isosceles triangle is formed by the two congruent sides. So the vertex angle is where those two sides meet. So right here would be the vertex angle. This angle up here. And the base angle of an isosceles triangle, or base angles of an isosceles triangle, are formed by the baseline, base of the triangle. Be these two angles down here. This one and this one. And those are going to be congruent because it's isosceles. Okay, so then let's jump into some examples. Number 1, examine isosceles triangles. Examine the diagram. Suppose that you draw XB perpendicular to YZ. Can you use SAS to prove triangle XYB and triangle XZB are congruent? Explain. So it is given that XY is congruent to XZ. Okay, they marked those for you, XY and XZ. and XB is perpendicular to YZ. We know that. They told us that up here. You can use the definition of perpendicular to show that angle XBY and angle XBZ are right angles. Since right angles are congruent, we know angle XBY and XBZ are congruent. Since XY is congruent to XZ, we can use the isosceles triangle theorem to show that triangle XYZ is an isosceles triangle. So we've got these two sides that are congruent, so it has to be isosceles. Now use theorem 4.1 to show that angle Y is congruent to angle Z. Well, if two angles of one triangle are congruent, we just proved that these two are congruent. And we know these two are congruent because it's bisected. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. That's theorem 4.1 from lesson 4.1. Thus, angle 1 and angle 2 are congruent by the reflexive property side XB is congruent to side XB. So, because YZ is congruent, angle 1 is congruent to angle 2, and XB is congruent to XB, the triangles are congruent by the side theorem. Angle theorem, use the diagram from example 1 without the tick mark. So we don't know that those are congruent for sure yet. Okay, so there's 5 steps there. Put your statements and then why you think they're true. Example 2, using the isosceles triangle theorems, explain why triangle ABC is isosceles. So, angle ABC and XAB are alternate interior angles, right? We've got these two parallel lines. ABC is this angle and XAB is this top angle. They're on opposite sides of the transversal, alternate interior angles. Formed by parallel lines XA and BC and the transversal AB. Because XA is parallel to BC, we know that ABC and XAB are congruent. The diagram shows that XAB is congruent to angle ACB, so this one is also congruent. So, by the transitive property of congruence, angle ABC is congruent to angle ACB. And you can use the converse of the isosceles triangle theorem to conclude that side AB is congruent to side AC. By the definition of isosceles triangles, triangle ABC is isosceles. Okay, so number 3, using algebra. Suppose that the measure of angle LM equals y. Find the values of x and y. So, right here, y is marked, and we're saying that LM is congruent to y. MO is perpendicular to line LN. This is given since MO bisects angle LMN. And this is what we were talking about with theorem 4.5. So then angle X equals 90. That's the definition of perpendicular bisector. Perpendicular means it makes a 90-degree angle. And X is one of those 90-degree angles. The other one's over here. The measure of angle N equals the measure of angle L because we've got these two congruent sides. So that is the isosceles triangle theorem. That theorem said since we know that these two sides are congruent, the angles opposite those are congruent. So if L is opposite MN and angle N is opposite side ML. So those two are congruent. We're given that measure of angle L equals Y. Since N equals L, then we know N equals Y as well, and that's the transitive property again. So by the triangle angle sum theorem, if we add all of these up, it has to add up to 180. So we know that angle N is Y. We know angle NMO is Y. That one was labeled up here. And we know that MON is X, which is 90. And it all adds up to 180. So then Y plus Y is 2Y. We've still got 90 and 180 here. If we subtract 90 from each side, 2Y equals 90. And if we divide each side by 2, Y equals 45. Therefore, X equals 90 and Y equals 45. Okay, number 4. Using isosceles triangles. So they're saying the measure of angle X is 120 degrees. The garden shown at the right is the shape of a regular hexagon. Regular, so all the sides are the same. So this side, this side, this side, those are all congruent because it's regular. That also means all of these angles are the same all the way around. So because the garden is a regular hexagon, the sides have equal length, so the triangle is isosceles. Are congruent since it's regular. By the isosceles triangle theorem, the unknown angles are congruent. So we're trying to figure out what these two corner angles are. The measure of the angle marked X is 120. The sum of the measures of a triangle is 180. So X plus Y equals 180. We're calling these two other angles Y. So we know X is 120 plus 2Y has to add up to 180. Well, if we subtract 120, we have 60 left. 60 divided by 2 is 30. So the measures of the angles of the triangle are 30 degrees, 30 degrees, and 120 degrees. Okay, so now there's a couple more check for understanding problems here for you. Number 2 says use the figure in example 2. Can you deduce that a triangle ABX is isosceles? Is there enough information there? Yes or no, and then explain what you think. And number 3, use the diagram from example 3. This time we're going to say angle L is equal to 43 degrees, and you're going to figure out what X and Y are from there. And then number 4, use the diagram from example 4. The path around the garden is made up of rectangles and equilateral triangles. What is the measure of angle Z? And this is a little bit confusing, but when they're asking for the measure of angle Z, they're looking at this outside angle here. So it'd be made of the equilateral triangle and the rectangle. So think about what all the angles of a rectangle have to be, what all the angles of an equilateral triangle have to be, and then if you add those together, you should get angle Z. Okay, go ahead and get started on that. If you have any questions, feel free to ask, and good luck.